So I'm just going to talk a bit about the process that comes after you finished your synopsis, which is where the evidence goes through expert assessment to put it in an effectiveness category, presented in our What Works in Conservation book, which is now Sylvia's job, who's just left. So we first produced this in 2015, and it's now updated annually. So we add in the new evidence and repeat the expert assessments to the best knowledge that we have. And if you look inside What Works in Conservation, which hopefully you have as it's knocking around, you see tables like this for each different threat. So here the threat is the invasive species water primrose, and this is a list of all the possible interventions that we've thought of that you could try and carry out to reduce it. And it's been through an expert assessment process, and it's put these different interventions into different categories. So there are 3 things that we think are likely to be beneficial for reducing water primrose. So chemical control, biological control. Physical removal has been assessed as unlikely to work, and then there's a whole bunch of things that we don't have any evidence for. And this is a pretty common state of affairs. There's often a lot of interventions that don't have evidence. This is a different intervention in the amphibian synopsis, which has got a bit more evidence and shows a couple of the other categories. So you can have a trade-off between benefits and harms. So it might help amphibians in some ways, but maybe have some negative side effects as well. There's unknown effectiveness, where there's some evidence, but it's not enough to make any assessment. And there's also unlikely to be beneficial, where the evidence suggests either it doesn't work or it actually has negative side effects. All this information is also present on our website, where it looks like this. So every action or intervention has an effectiveness category, which is colour-coded, the same as in the What Works book. And it shows you that when you click on the intervention, and also in the full list of interventions if you're browsing through. So how do we get these effectiveness categories for each of the intervention? We carry out expert assessment, which is something that Bill's a great expert in and has lots of experience of. We use a panel of experts, and we send them out the synopsis once you've completed it, for them to assess each intervention in turn. And as you may have seen from the previous slide, we asked them to measure 3 things, or assess 3 things. It's effectiveness, which is whether it works, and this will be really high if there are lots of studies showing that something is really quite effective. Certainty, which is how confident we are about our assessment of effectiveness. So we'll take into account things like the number of studies, how consistent they are, so if they're all showing a similar effect, that'll increase your certainty. And also the quality of the studies, which is something we've been talking about quite a lot today. So if they're controlled, randomised, replicated studies, that would increase our certainty. And then we also ask people to look at harms or side effects, which refer to the target species. So an example of this might be, say, you had a ground nesting bird and you marked its nest. That might reduce nest loss due to farmers running it over with a tractor, but say predators learned to find the nest because of those marks, that might be a side effect. Another example might be if you're controlling corvids to help ground nesting waders, that's obviously bad for the corvids, good for the waders. And all these are scored as percentages between 0 and 100. And we then use these 3 scores to put each intervention into a category. And we've devised a scoring system that looks like this. Don't worry about all the details now, but basically we look at certainty and effectiveness and harms. So if something's got uncertain, we basically call it unknown. If it's got a reasonable level of certainty and a low effectiveness, it's likely to be ineffective or harmful. And if it's in the top corner with high certainty, high effectiveness and low harms, then we call it beneficial. And that's another way of presenting that. And all this is in What Works and also on the website. And just a little bit about sort of why using experts is a good thing to do and some of the things you need to think about when you're doing it. The average of several people's opinion is likely to be more reliable than just asking a single person. So we generally aim for between 10 and 20 experts on an expert panel, and we take the average of their scores to produce our final category. It's really important that the experts only use the information in the synopsis so that they're all assessing the same thing. They're not thinking, oh, I know this happened, and bringing that in. We want them to use their experience to interpret the information. So, for example, if they know this is a really strong, important study, they can give that more weight, or this one was not that relevant to the intervention. But they've got to base their assessment on the evidence that's presented to them. And the approach we use is a modified Delphi technique, which means that we have several rounds of scoring with some discussion and exchange of information in between. And this has been shown in a variety of studies to lead to improved reliability and agreement in the scores. Just to quickly run through the process we go by, so we send out the synopsis to the experts. We ask them all to score those 3 measures for each intervention. We then calculate the average from their scores and circulate that. So we'll put the intervention into a category, present its effectiveness, certainty and harms, and any comments that people have put, so people can also add comments at the beginning. So this is a sort of exchange of information round, and we then ask experts if they want to revise their scores, and they may or may not, or they may for some, if some of the information sort of makes them interpret the evidence in a different light. Normally we just have 2 rounds. Sometimes there's a 3rd round. If we have, for example, a workshop or something, there might be a 3rd round, but generally now we just go for 2 rounds, calculate the median effectiveness, certainty and harm scores, and use those categories I showed you just now to put each intervention into its effectiveness category in What Works and on the website. And it's really important that all the scores and comments are done at an individual level and kept anonymous so that people aren't influenced by one really charismatic person or what other people might think. So they can discuss their ideas, but when it comes to the scoring, they're all kept completely anonymised when they're recirculated. A couple of points to remember. People sometimes get confused about lack of benefit and lack of evidence of benefit. And we try to make this as clear as possible in our phrasing on the website. So lack of benefit is there is some evidence showing that something doesn't work. There's a lack of evidence for benefit is there isn't any evidence, so we don't know whether it works or not. And the other caveat that goes with all the information in What Works is that it's a really, really crystalline, really, really summarised version of the evidence. So it's like key messages and the assessment. And it's really important that people don't just go, oh, that's the top of the table, I'm going to do that. We hope that it gives people an overview of the evidence and it summarises all of it in one place, so it's good to get an idea of your options. But it's really important that people go to the full evidence summaries on the website and also ideally the primary literature before they start making any decisions. So we are now going to do a quick exercise where you can all be experts on bats. So a slightly modified version of the evidence that is available about putting cave gates on bat caves to restrict public access. So it should all be on the page in front of you. Maybe if you just have like 10 minutes to read through the evidence, and you all have 6 post-it notes on the back, 3 for the first round and 3 for the second round. And if you could write, independently and anonymously, your effectiveness score on 1 yellow, your certainty score on pink, and side effects or harms on orange or green, because I ran out of orange. And hand them in. Yeah, we'll do that at 1:45, say. So the question is, how effective are gates on bat caves for enhancing bat conservation? Sorry about the misleading intervention on the side, but this is just to show you how this each different scoring system goes from, so no certainty to high certainty, ineffective to very effective, no side effects to major side effects. So you might want to take into account the number of studies, the quality of the studies. So we're now going to do what we did in the expert assessment and see what the median scores of each of these are.
Yes, I think that's that.
Okay, so these are the median scores of you, a group of experts. So we've got effectiveness 22.5%, certainty 50%, harms 55%. So I think that means it falls into, I think that line is at 40%. I think we are ineffective or harmful. Do you agree with that? And is that the category you think it should be? So there were 4 studies I gave you.
Yeah, so the 4th study, maybe the controls on tourism, the restrictions was the intervention.
Yeah, so that would be one of those studies that we would write up, probably, if there was one on restricting people.
Yes, yes.
And you could write it up as both, but under both you would have to say the 2 things happen together and you can't separate out the 2 effects. If there were a lot of studies that tested different designs, then maybe when it comes to synopsis writing you could split up and say these are the ones that have spaces of this size or were made of this or were on this species of bat, and then maybe that would say, okay, it works better in these circumstances than in other circumstances. our harms category only refers to the target species. It could be any species of bat, so you could put the gate up for one species of bat. Maybe this is not so relevant for this example, but for example birds, you could do an intervention for one species of bird, and if there were harms in the same studies on other species of birds, you would count those, or on the same species. But if there were harms to mammals or invertebrates or whatever, we don't include those. So yeah, it's quite difficult, and if you're going through like some of these interventions have say 20 or 30 studies, you might be trying to weigh up the effectiveness, and hopefully some kind of prevailing picture comes out, but it doesn't always. And then sort of the different things you need to take into account with the effects of uncertainty, and then and often because in one or two studies the certainty is low and it will go into unknown effectiveness, whatever happens, so that's fairly straightforward. But when you've got a few studies with conflicting results, it can get complicated. Doesn't sound like things will change much, but since we're doing a Delphi technique, do you want to have one more round? Anybody wants to change their score at all? So when we've redone that, I would say that if we were looking at it, if we had it all in a spreadsheet, we could look at it more clearly, that everybody's bunched up together. There's a lot of 50s here, there's a lot of 60s here, there's a lot of 20s here, which is kind of what you'd expect after some kind of discussion, and hopefully the more informed people persuade the less informed people with their evidence. So you were obviously very good experts first time round, so the category and the scores have not changed much. Maybe I could choose a more controversial example next time. But I still think, it's sort of demonstrating the process about exchanging ideas and rescoring needs to have greater consensus and reliability of scoring. Any questions about that whole process?
This is a critical point if you want to do a synopsis, because usually doing a synopsis is a full-time job, something like that. So presumably the person is paid. But acting as expert is not one day. It's not a one-day work. It's for many action and many species. It could be
It's normally
ask for quite an effort, and so I think it's not so easy to find volunteers that can work for a week just to review the synopsis and be an expert.
So we do have two different groups of experts. So the expert advisory panel for your synopsis may contain the same people who are used for the expert assessment, but it doesn't have to be the same people. Often there's overlap of people who are interested and involved in the process. And for example, I did the assessment of the bird synopsis, which is a massive task. There are like 300 and something interventions, and we split that up. So we gave some people about 50 or 80 interventions to judge, and we sort of split the group, and there were also quite a lot of experts, so we could split the task up. But it's true, it is a significant undertaking, but we have to hope that people believe it's worth it, really, and just be realistic with people when we approach them and say, this is the amount of work it's going to be, this is when it's going to be. And we do get people dropping out, inevitably, so we try to ask more people than we're going to need in the end. But it's really important to us that we get the people who are high up in these fields, in conservation, research, policy, practice, whatever, involved, because if they're not involved and on board, then it's not going to get used. So I would say the expert assessment is probably a few days' work on average. Once you get into them, you can read them and make some kind of assessment within sort of half an hour or something per intervention. I mean, I guess we just did it in 10 minutes. And then there'll be a lot with almost no evidence where it's really quick to do. So I would say that's not atypical. So, and you can do it in an hour here and an hour there. And we normally give people a week or two to do the job, and because if you give them longer, it doesn't make them any more likely to do it.